All right, hello everyone. My name is Ali Almutawa. I'm giving a talk about stud ranges, range adapter closure, but better. Okay, hopefully. So before we begin, just a little bit about me. So I'm a student at the University of Colorado Boulder. I'm a senior right now, and I'm the main developer of Mapper. It's a graphics library that I'm making so far. It's not done, but it's on the way. And I've basically obsessed with C++. I've worked as a learning assistant for the intro course at my university for a year, and then also a course assistant for the algorithms course for 1 semester. So a year and a half of experience, I would say. I'm an aspiring YouTuber, hopefully starting my YouTube channel. Just have one video so far. Gonna come out soon. Don't do it. Okay. All right. And then that's my GitHub username. And this is my first talk ever, so please have fun. All right. Also, please feel free to ask any questions, interrupt me at any time. Just raise your hand. I'm gonna look at you and someone's gonna give you a mic. Don't wait for me to finish, just ask a question, okay? So what is range adapter closure? Does anyone have an idea? It's gonna be an interactive session, so please. No one? All right, so it is a C++23 feature, and according to CPP reference, there's a whole definition for it. But what it basically lets you do, if you define a struct and that struct inherits from range adapter closure, you overload the operator paren, and it gives you this extra functionality, the piper thing, like the Unix syntax for the terminal. So these two are equivalent. This operator will end up calling this operator. Does that make sense? All right. And so if you read the definition, you're going to realize that this is a CRTP base class, which I don't think anyone or most people have familiarity with it. Does anyone know what CRTP is? All right, on the back. Someone's good. Why was it called that way? Yes. Right, which is a weird thing that. Okay, let's explore this more. Oh, repeat the question. That's right. So, what's your name? Good. He said it was a curiously recurring template pattern because it was curiously recurring, and someone noticed that and just named it that, I think. And so my initial thought when I saw this was like, what the heck is CRTP? And then I watched some videos, mainly Jason Turner videos, and according to him, it's where I'm inheriting from myself or from a template and passing myself as a parameter. Yeah, episode 259, C++ Weekly. It's considered kind of like compile time inheritance, which allows you to add functionality at compile time. It's kind of cool. You should try it. Okay, so I'm going to show some example code from CPP reference as well. You can see slice is inheriting from range adapter closure and passing itself as a template parameter. And then it also overloads the operator call. You can see it takes a string view and returns a substring based on start and end position. Okay, so the way you use it, you create an object slicer. You initialize the start and the ending variable. And now you can either do slicer of string, and that's going to give you the slice string, or you can do string piped into slicer. And this will do the same thing. All right, so that's one functionality of it. The second thing that range adapter closure gives you is composing functions. So you can compose a slicer object with drop while, and then you can get a function called slice and drop. And now we can call that function or pipe into it, and it's going to slice it, and then it's going to drop while it's not equal to 3. And this will print 1, 2. Did that make sense? What's up?
It did make sense, but I'm sorry, it's something I never felt like before. You're showing me that outside the context of ranges entirety.
Yeah.
You can just call a function with pipe syntax.
You say that again?
You can just call a function using the pipe syntax outside of the context of range. Like on SC2 equals SPR pipe slice.
Like you're saying, it doesn't have to be a range to be called with?
That's what I'm asking.
Yeah, it can be anything, I think.
Okay.
Well, not range adapter closure, but my better implementation is going to be that. Okay. So can anyone see any problem with this design? Well, that's one thing. Also, they're using /n though, which is better than endline. All right. So for me, at least, when I saw this, I thought it was kind of limited. Let me just move that a little bit out of the way. It's limited because the function operator prevent can only take one argument, which kind of makes sense because how are you piping multiple arguments, multiple things into a function? But I thought you could do that by passing the rest of the arguments into the function, just the first argument as a part of the pipe. okay? And because it can only take one more than argument, then it's not general because every customization needs its own instantiation of the objects. In this case, if I want another slicer that does it from 2 to 7, for example, I'd have to make another object that has start as 2 and is 7, which is not practical. And so the way I want it to look like something more like this: you slice string 1/6, or you slice into, or you pipe into slice 1/6. Okay, does that make sense so far? Cool. And so any ideas how to fix this issue that I'm looking at? No? No one? Yeah, me neither. Well, I'm just kidding. So how I decided to go about this. I'm gonna use a CRTV base class. If the standard library used it, it's probably a good idea, I'm thinking. And so that's gonna be the main thing in here. I'm gonna use concept as much as possible since we're using C++20. I guess why not? Just make it better. And I'm gonna try const X for all the things. There you go. All right. And then I will attempt perfect forwarding, hence the imperfect forwarding. I don't think it's good, but we're gonna look at that in a bit. So there's 3 parts to this implementation. First of all, the CRTV base class, which is, we're gonna call this one Piper. I'm gonna call it, instead of stored ranges, range adapter closure. Okay. So the second part is the operator pipe, which is where the match is gonna happen. It's gonna be a little bit messy, but we're gonna look at that in a bit. And then the last thing is the user-defined class, basically how our base class is gonna be used by the users. Cool. So let's start with the first one. I have my template class called Piper. All right. Before we go on, let's think about the use case more, because this is going to be a little bit complicated. So I want to be able to write this syntax and this syntax, which implies that slicer will need to have 2 operator parents. Okay, one that takes in all the parameters and one that takes in everything except the first one. So let's maybe start by defining that class. So you have struct slice, inherits from Piper of slice, and I'm defining the 2 operators. This one will return the substring. What about that one? What should this method return? Any guesses? I'm gonna give you a hint. It's not a string view, because there's no string view. So
a function that takes a string view?
A function that takes in string view, more or less. I like what you're thinking, but why would you do that?
You need a closure that captures those parameters?
Yes, I want to capture these parameters, okay? But a closure, are you doing currying in a way?
Yes, that's what I'm implying.
Right, but is that how range adapter closure is used?
I have no idea.
No? Okay, so that could work, but I don't think it's going to work for my use case. And so before we answer this question, let's remember the use case, and let's think about this operator. This operator needs to call the big one, the upper one that you define, right? And so the left side of this operator is this, which I still haven't figured out what's going to return. But let's try and define the operator pipe. So I know the left side is going to be a string view. It's all good. The right side is going to be something that I'm not sure what it is about. And I'm using the abbreviated template syntax in here in C++20. So it's something I don't know what it is. But I know that, as Jason said, it's going to hold these 2 values together. It's going to give it to the operator pipe. Okay? And so what can hold more than one value? Tuple. That's good. Who said that? Good job. So a tuple. And so I can make this return and make tuple of these 2 variables. And that's, now I can fully define my operator pipe. Okay? So remember, this operator is going to call that big one. So let's define it. Oh, wait a second. I do not have access to that operator. I need an object of type slice to access the operator paren. Okay? So there's many ways to solve this issue. The way I decided to solve this is by packaging it together with a tuple. So I made a struct that holds a slice pointer and my tuple of arguments. I guess that's one way of doing it. Cool. So now I can modify the class. Instead of returning a make tuple, it's going to return a package with my this pointer and my start and end position. Does that make sense so far? Any questions? No. Okay. So now I can fully define my operator pipe to take a package and it then accesses the object. It accesses the operator call, passes the string view, and then the rest of the parameters. Cool. Okay. We more or less have a working implementation. We just have to do a couple of things here and there. So we need to hide implementation details, mainly the package thing. We need to generalize it using templates and constrain it using concepts. Cool. All right. So can we generalize anything? Actually, can we, what was the first? Can we hide any implementation details in here? It doesn't really make sense because this is a user-defined class. It's not for us to hide implementation details. So nothing to be done in here. Actually, there is something. We need to hide the package thing from the user. I don't want the user to know what package is. I want this to be hidden, not for me. So I will delegate it into my parent class, and it's going to take care of everything. So this turns into something like this, kind of ugly, but I'm just casting my this pointer into my parent class, and I'm accessing a method called makePackage that takes the arguments, and then it makes a package for me and returns it back. Okay. And so if ever makePackage gets something goes wrong with it, and I want to change it, the user doesn't have to change their own implementation. Make sense? Okay. What's up? It's not. It was because I think I consted this method and the compiler was giving me issues. But I'm removing some details in here as like not const expert, so it doesn't fill the slides. But I think once you add a constant, when you make it a function constant, this would be required, I think. Make sense? All right. So let's define the parent class, the one that we looked at the beginning of the talk, but we haven't defined yet. So since we delegated the call to it, we need to define a function called makePackage. And this is how it looks. It just returns, it downcasts itself, and then it also makes a tuple of the rest of the arguments. And so because it's a CRTB-based class, this is allowed. You can downcast yourself. This is not usually allowed, but trust me, it is allowed. Okay? There's a big reason why it is. I don't think you even mentioned it in your video, Jason. You were like, for some reason, the standard allows this, and that's it.
I think that episode 2 years ago.
Yeah, that's what I figured. Okay, so this is well-defined behavior. Cool. So we just kind of hid implementation detail. What about generalizing it? So can we generalize anything in this part of the implementation? String view, I guess, but that's also user-defined, so I don't care about that much. My part of the implementation is the package, for example. Can I generalize this? Yeah, what do I do? And for now, this is just a package that takes a slice and the parameters for a slice. Can I just make it, what's up? On the tuple, how do I do that? A bunch of arguments. What about this part of it? That could also be generalized, right? So I can take a template, T, and a bunch of arguments. And then I would make the object any type, T, and make the tuple just a bunch of arguments together. Are we good? Okay, so that's my package. Can I generalize anything in my parent class? Should have seen it.
Those integer parameters.
Yeah, these integer parameters, I want them to be anything. So I'm just gonna, why is it not working? There you go. I'm gonna make it take a template of arguments, and then I'm gonna change that to take a bunch of arguments and then expand these in the tuple. Are we good so far?
Just in case you weren't planning to do this, I think you should go line by line what that code is doing.
Okay.
To make sure everyone is following along here.
Okay.
Yeah.
So does everyone know what a variadic pack is? Okay, I see a lot of nodes. Does anyone not know what that is?
People aren't going to raise their hand if you ask them if they don't know something. If everyone else, they think, just nodded their heads and said they did know it. So just explain it.
You don't know what they are. Okay, that's good. So once you call the function, this can accept any number of arguments. And all the types will be packed together in this big type args. And so what I'm doing here is I'm downcasting this pointer again. That's going to be the pointer in the package. But then I'm just expanding my variables with the ... operator to go into tuple. And that's how it works. Kind of fancy. I like that. Okay, so that's good. We're good on this page? Okay, so that's generalization done. What about this operator? This gets a little bit messier. Any ideas? What about for the first part? It's always taking string view. Can I change that? make it take auto, probably. Auto is good. What about the second part, package? Because package now is not just a single struct, it's a template of a struct. So I need to pass the template parameters for it. Make a concept. I love that. That's exactly what I did. Because for the other solution is just to make a template parameter, a type name, which is really messy, and I don't want to get into that. But a concept, and then just basically say that this type has to have a .obj and a .args, and that's it. Theoretically, any struct that has an obj and an args would work with this concept. But frankly, I don't think anyone is going to do that. Well, you never know, but okay, so that's good. I'm going to make this concept. And so now my string view is an auto. My package is a packaged concept. What's up?
I'll try to be good and use the microphone. What happens if you don't constrain either parameter? You just say auto. That won't compile, will it? Are you allowed to do that?
What do you mean?
Are you allowed to generically overload all the operator completely?
I mean, it does compile from.
No. I'm saying if you removed packaged.
Oh.
You can? You have a bad day? It will compile? I thought you had to
I guess it will compile if you never use it.
Well. Huh. Okay.
But I guess, yeah, the constraint does save us from a lot of issues. So that's good. Okay, and so what am I doing here? Because I want to expand the parameters. What's up? Uh-huh. Am I what? Well, I didn't know std apply was a thing. I only knew std invoke, I think. That's very, I didn't know that was the thing, okay? And the question was, am I going to use std apply? I'm not sure what that does, actually. Can you explain what that does? Microphone coming. Yeah.
So std apply is a function standard library. It takes a tuple and a lambda typically, a callable. Yeah, you can write a generic lambda, and the arguments that you're given are the tuple elements.
So it's doing what I'm trying to do here.
I think it's doing exactly what you're doing there.
To be frank, this was a template type name, and I was expanding the tuple with types expanded. But once you have two ints passed in, that's ambiguous, and so you get a big issue. So and then I resorted to use an index sequence. It's my first time ever using it. So I think what it's doing, first I'm getting the size of the tuple, how many elements are in there. And then I have a helper function that takes the index sequence and my package and my string or whatever object that is, and then it just does the expansion on the indices. So it's taking an index sequence and then expand the tuple or to the tuple on the index sequence. Make sense so far? Okay, so this is generalized. That's good. How do we constrain it? Let's see. Can I do anything here? If you want to, but I don't. What's up?
Is int the proper type to be passing this up?
No, size_d is, but I.
Are you not leaving conversion warnings?
I don't think this is the. No, I only wrote this code for the slide.
I'd say that int is right and size t is wrong.
Oh.
No, int is definitely not right. You might argue that.
Long int. I don't know.
Yes, you might argue that long int is right, but int is definitely wrong.
Can a size be negative?
Well, he would like. There's a certain subset of sect. Let's say sect of the C++ community that says all the sizes should be signed.
I do not agree with that. I don't like that.
Yeah. There's a certain sect. You should talk about it at the burns.
Is that where you have the literals z and uz?
That's one reason we have z and uz, yes.
Okay, interesting.
Yes.
Yes.
Okay.
Correct, right,
yeah,
right,
There
yes.
you go. Setting clear.
Correct answer is like sign versus unsigned is the wrong question. You should have index type and offset type.
Oh, now that gets complicated. Okay.
Yeah,
I'm gonna stick with an int. No best practices here. Sorry, Jason. But I think this is good. What about this package? Can I constrain it using concepts? By the way, I guess I shouldn't ask the question, but does anyone not know what concepts are?
I don't know what concepts are.
Okay, very good. Also, there's another person. So concepts, let's look back at the previous concept because I like that. Okay, So what this concept is saying is that whatever type you give to it has to have these .obj or .args. Otherwise, if this doesn't compile for that type, then the whole program doesn't compile. And what I'm doing here is I'm doing package auto. So this auto type, whatever it is, gets past that concept, and it just makes sure that this works for it. So just constrain the type for only the types that have these obj and args fields. Make sense? Okay. So now we're done with this. Can I have any concepts for my package struct? T gotta be callable. That is correct, and I didn't think of that. But it also has to be a different, also has to have a specific feature, I guess. Exactly, derived from Piper. Okay, so let's move this down a little bit. I'm gonna write a concept. It looks ugly, but it's saying that my type or my Piper of T, removing CVRef, has to be a parent of T itself. And this is basically saying that the type has to be a Piper type. It has to be inherit from type, from Piper. What's up?
So there's a standard concept which is derived from.
Oh, say that again?
It's the same as yourself with the.
Can it be used in concepts?
It is a concept.
It is a concept. Okay, I didn't. Oh, there is. It's not a question. It's a comment saying that there is a concept saying is derived from. Is derived from, which basically. Oh, derived from, which basically says that the first type has to be inheriting from the second type. There you go. And so it's the same thing as this, but just the parameters are opposite. Okay. Is it any different from this? Like, why would I use that one over the other?
It would be semantically the same.
It would be semantically the same. That's what you said.
So the reason to use concepts here in general would be that you get concept subsumption. You only get subsumption with concepts. You can't get it with type traits or context rules. So if you were building a tree of concepts and you wanted concepts that subsumed other concepts, you'd want to use concepts.
That's a type trait.
Yeah.
And that other one is a concept. So I probably
Correct.
should have just used.
Derived from is the concept.
Okay, that would have made it.
It says the same thing as his base of. It's probably written in terms of that.
Yeah, I see what you're saying. I guess it would have been shorter, but.
That doesn't even need his Piper type.
Yeah, I don't need that. I can just do derived from Piper of T and then T, and that would work. Yeah, but whatever, this works. Okay. So I'm just gonna change this to be a Piper of T, and that's basically it. What about, no animation. What about this class? Can I constrain it? Yeah, I don't see anything either. All right, moving on. So back to that. Say that again. Piper of derived. I'm gonna be honest. I tried. Okay, what's up? Say it again.
Yeah, the derived in some way needs to be invocable.
Derived needs to be invocable. Can I have a
with
concept?
Piper and args? I'm not sure.
Piper is not invocable. Yeah, the child has to be invocable. You're correct.
Right.
That's one part of it as well. Can I have a concept saying that the derived has to derive from Piper? Or is that going to be a loop dependency? That's a question for later.
Maybe.
Maybe. I mean, I tried it. It didn't compile, but I'm not sure why. So.
What that is saying is that down on your make package, you can constrain the args to be a set of arguments that will work with each other.
Right. That's one thing as well. Okay. You guys are seeing a lot of stuff that I didn't see, but for now this works. By the way, Jason's comment was to make to constrain args to be a set of arguments that derive can call on. Yes. Okay, it's can't call with.
Yeah.
Right. English is weird. Okay.
Is invocable.
Is invocable is the thing. That's
Invocable,
right. Yeah.
Oh, you're talking about. I'm sorry. I'm going back to the type trait, not the. Yeah.
Okay. So usually, if you add an is, it's going to be a type trait. Okay, I see. Okay, so this is good for my use case. I'm gonna change this later. Can we change this? Constrain it, not change it. Give you some time. I mean, I gotta say, if Ben can't see anything, I don't think there's anything in here. I don't see anything either. Okay, so we just constrained it. So, whew, we're done. Kinda. Are we really? Did we miss some key feature? Well, okay, you're gonna see that in the implementation itself. I just didn't put it here for the slide. But anything that's important.
He said anything that's important.
Oh.
Well, no, when I said const expert, he said anything that's important. So it's important.
No, const expert is important, as well as perfect forwarding and no discard and all that stuff. Don't worry, we got it.
We didn't mention that at all.
Yeah, not yet. Okay, so I think when I saw this, I thought we were done. Well, not saw this. When I did this, I thought we were done until function composition came in mind. I was like, shit, I gotta do more work. So how to approach this? Okay, I made these slides this morning and I didn't test them yet. So let's see. Let's think about the use case. I want to be able to do, well, ignore the first part. I want these three to be composable. I want to create a function from the filter and then map and then folding in a single object. Okay, so this is equivalent to this, and that's what I want to do. I want to be able to write map fold is equal to map of doublet piped into fold, and this will create a new piper that can take a range and it's going to map and fold at the same time. Okay, and so because the top can be written as the bottom, I just minimize the problem to just being able to pipe two functions, and then just writing that I'm going to be able to compose multiple functions at the same time. Okay, so let's see how we can do that. So I want to be able to compose these two, which is equivalent to writing them inside each other, right? That's basically the definition of piper. And so what I can do is I can use my pipe class to write another piper that will take two functions and then it's going to compose them together. So let's see how that kind of looks. It's a little bit ugly. It takes them to the two functions, and then its operator call is going to be f1 called on the parameter t, and then the output of that is going to be called onto f2. So it's one inside the other. And then I just write my make package function, and now it's pipeable because it's derived from pipe. Okay, so now I have the pipe syntax for composing functions. Is that good? Does that make sense? It's time for a demo. Okay, just to show, whoa. This doesn't compile.
That doesn't compile.
That's a slide code.
Yeah, okay.
I just want to pass the idea.
Okay. I just had a question, but
Can you use the injected class name there where you're doing the static cast, or do you need to say composed of P1 and P2?
Can you use the injected class name? What does that mean?
Wait, is it composer
Oh,
or composed?
It's composer.
Right, right.
What about that?
So I think you can use an injected class
Well,
name.
in my
rather
code,
than-
I use composed, and here I use composer.
Okay,
And that got mixed up.
but they're the
That
same.
should be
Right.
composer.
Composer, right?
Yeah, it's a piper of composer of F1 and F2. These, yeah.
Okay.
Yeah.
So I'm saying I don't think you need the template arguments to composer
You don't?
because you could.
Oh,
it's an
because I'm
injected
inside
class name.
composer.
Yeah.
Yeah. Well, redundancy is not gonna kill us all. Okay. So let's do a live demo, and hopefully that's gonna work. Let me pull up my VS Code. There you go. Okay, that's gonna be a little bit messy. Okay. Okay, I'm gonna show the use case first, so it makes more sense. Can I do this? Is that good?
no, make it bigger,
Bigger?
bigger.
Is that good? Bigger?
Ask the back row.
Back people, can you see? More or less? I'm gonna do one more.
There you go.
Okay. Oh God. Okay. So look at fold. Okay. This is my implementation of fold. It's a very messy, but It inherits from piper of fold. It takes a range. It takes an init value. And look, man, I'm using invocable on init and the range value of v. And then I have default parameters to be init to be 0 and the function to be std plus. Yeah, I don't know, because I'm only using it on int for now. But I can just take them off.
Okay.
Okay, and then fold, it's basically accumulate for the C++ people, by the way. You just takes a range, an initial value, a function, keeps calling the function on it, and returns you the result. Okay, and I also have map, which does the same thing. It just calls the function on every element in the vector or in the range and returns you the new range. Okay, and I also made filter. If the result of the function is true, insert it. Otherwise, drop it. Okay, so I made these helper functions. Now I can use them in main. So I made this first example. So I made a string view of my name, or a string, not a string view. And I made, oh, actually, I did make slicer. Let's look at that, because that's my first example. This is the one that you saw in the beginning of the using std ranges adaptive closure. It takes, now these parameters are not part of the other class. These are part of the function arguments or parameters. So that's what I wanted to be able to write. And then I have this other operator. Okay, so let's see how that works. I have my name, and I have the slicer. I initialize it. So now I can create an object that only takes the first 3 arguments of, or the first 3 letters of my string. And I have another piper that's called capitalize. It's going to take it's going to map the string to upper. And now I can compose these 2 functions called cap first 3. So it's going to capitalize the whole thing. And it's going to take the first 3, and I can print these. So let's see if I make, and I run piper. Look at that, I get Ali. So it works, it's very good. Let's comment this out, and let's look at the second example. I just have a vector, 1, 2, 3, 4, 5. I have filter, double it, and double even sum, which is gonna, it's basically the example in the slide. It's gonna filter out the evens, double them, and add them. So if I can do math correctly, that should be 2 and 4, double them, 4 and 8 should be 12 in total. Okay, so let's print that. So I'm piping vec into double even sum, and that also works. And I get 12. So it works. Now, if you want to look at the implementation, that's going to be a little bit hideous, but you can also give me some good suggestions, like invocable. That's a good one that I should put in here. So this is my concept. This is a forward declaration of my class that has this requires clause, because I add this later in my definition. And then this is my package concept, the only thing that looks exactly as it is in the slide, which is kind of cool. And then this is my package, which just takes a D, and then which is derived in a tuple of arguments. And then this allows you to call, if you create a package, and then you want to, instead of piping into that package, you just want to call it with parentheses with the parameter itself, then it does that for you. It allows for regular syntax, if that makes sense. Okay, there's a lot of subtleties to this thing. If you call it with no parameters, this is just no op.
Why did you put inline on line 27?
I just put inline constructor and everything, just to make sure.
No, don't just put inline on everything.
Does it have a negative effect?
It has no effect. Const expr implies inline, first of all.
Well, that's good then.
And second of all, trust your compiler as a default.
No.
Yes.
I've been through stuff. So, okay. This is my piper class, which just has the package. Look, I use no discard. Are you proud of me? So it's an inline const expr, I guess it's implied, and it's const as well. Yeah, I don't give a lot of attention to this comment. It happened like a week ago, and I was like, okay, fuck it, I'm not gonna do it perfect. I had std forward in here, and I had my parameters to be universal references, and then that just kept not giving me the correct output.
You probably had a lifetime issue where the objects passed in were being destroyed before you used them.
Yeah, thank you.
Yes, yes, it's a lifetime issue.
Yeah.
ASAN would find it easier than UBSAN.
Probably. My guess is that because when you package it, with an R value, for example,
Yes,
the package is not the owner anymore, or is not the owner,
right.
so it gets destroyed. And that's-
Exactly.
Yeah. Okay. So that's good.
Yeah.
I
You
did-
you have a reference to an object that was temporary on the stack that got destroyed.
Right.
Yes.
Yeah. So I guess if you opt into using a piper, then that's some overhead, but you opt into that. So I'm still doing the.
Yeah, that's a good point. How are you making the tuple?
I'm just expanding it.
You're passing them. Yeah, but what are you passing them?
It's just it's a template.
No, what is the type of the tuple?
Oh, it's well,
It's just the types.
yeah, it's just the types. It's
It's
a
the-
template of
just
types.
the
Give the types, and that's what I do.
In package, it's just a two.
Yeah, so it's going to make a tuple of references. That's why. So if you decayed the types,
That would
be
work,
safe. Yeah.
But it's the same thing as I'm doing right now, or is this lower?
What you're doing right now is making two copies always. You're making a copy at the function call site, and you're making a copy when you pass it into the tuple.
Okay.
If you did the decayed and then took R value references in a perfect forward, then you would possibly decay or reduce that to one copy.
Okay, I see what you're saying. Okay, so that could be fixed. Now, this is my piper helper that we looked at. This is my compose struct, which cannot fit on the screen at once, but I tried to do perfect forwarding for this one. And you can see it does exactly what I did in the slide. It's just returning P1 or P2 of the types. All right. And then I have my make package function. And then now there's something that's very subtle that caught me, which now I have two things that can be piped into. Piper type and a package. Okay. And so for using the operator itself, that's not an issue. But for composing, I need to know which type it is because my composer only takes package types. And so for this problem, in my operator pipe, when I give it either two pipers or two packages, I extract the packages from the pipers if there are any. If there is none, I just give it to the composer. But that's why I'm doing a bunch of if const expr. Just doing every case. If one of them is piper, or if none of them, or if all of them. Okay, so it's a bunch of if const expr, but they just return composed of these types with the package itself. And then lastly, I have my operator that I showed on slide. And then this is ensuring that the left side is neither a package nor a tuple, because that means that I don't want to compose, I actually want to call the function. So there's two different things in here. And then this is just a macro that I tried, but it didn't work. That's the whole implementation. It fits into 100 lines. I don't know if this is good code, if anyone wants to use that. But I think I like that a lot. I'm going to use it in my codes. What's up? Could you repeat that again?
You could make I think you can make the pipe operator a hidden friend so that it's found by ADL, and then you won't have to do that ugly constraint on the left-hand side.
I see. Okay. That's ADL's argument dependent lookup, right?
Right.
Okay. So that's a good idea.
Would you mind quickly explaining ADL, Ben?
Quickly?
Okay.
Do you have a class on this, Jason?
I don't.
So argument. So normally, when you call a function, normally that function needs to be somewhere in scope, right?
Mm-hmm.
If it's not, the compiler also considers the arguments you pass to that function and what namespaces they're in,
Right.
and it looks for the same function inside those namespaces.
That's why you
And
could
the idiom I'm talking about is where if you have a class that you want to overload an operator on, typically a good practice, some would say, is to make that operator a private friend function inside the class. So it will basically at that point only be found by ADL.
Right. Okay. But then does that really prevent issues? Can any other object call my operator?
It will only be found if you are passing a packaged to operator.
Right. But then if I constrain that, these are basically equivalent, right? If I put it outside the class, but have my concept, then it will be only found.
What you have works, I think, yeah.
Well, I
Right.
thought Ben was going to get ready to go up and demonstrate the.
So, by the way, argument dependent lookup, what I know is that this is why stood forward can work without stood, because there's no other function in scope right now that is called forward. So it's going to look in the standard namespace and this would compile. Same thing with std get, I think. You can just do get of the thing, right? Like this.
So does this one would not?
That could, well, not anymore.
Yes.
Are you sure? Okay. I swear this compiled at some point.
It might have accidentally compiled.
These, well, these are stood string.
Yes.
Because string is in the stood namespace. So that's stood full.
Interesting.
But in general, no.
Okay.
Get works with stood tuple, right? So tuple is always listed.
Makes sense. Okay. Because get doesn't work on any. By the way, his comment was like, was what I said was wrong. Okay. So, any questions on this whole ugly mess?
Yes.
Okay.
Your operator, there's something, sorry, I don't want to talk into the microphone the whole time, but I gotta, the ones that return packages.
That returns packages?
Yeah.
It's the one in Piper, which is this one.
But then you do the one in the composer.
Yeah, this calls make package of the Piper. So where's the composer? It's right.
Yeah, like on line 70. That's what I'm looking at. So there's nothing else that looks like that?
It does. Well, like if you look at maybe the fold example, you can see that I'm doing static cast.
Yes, right. Okay. So I'm pretty sure. No, never mind. Oh, wait, maybe. I was just wondering if your CRTP base class could implement the packaging one for you in a generic way and know that it would know that it knows that the CRTP derived class would have the other call operator, so it would know what it needed to do. Does that make sense?
Are you saying that this operator should be just done in the parent class?
I think it could be.
I thought that the same, okay? Otherwise, I wouldn't have it to be this ugly thing.
Okay, I didn't know if you.
But I think the issue was because I already had two different overloads of the same operator.
Oh, then you have to use using operator paren to pull them both into the same scope so that it would work.
Maybe I haven't tested that.
That should work.
Okay, I could try that. All right. Any other questions? Good comment, by the way. Yes, Ben? Wait for the microphone.
I have a big question. Have you tried deducing this?
No, I didn't. I don't think I would need that. Where would I need that?
No, because no compiler supported yet, Adam.
Actually?
Some do. Circle does.
Okay. There's another question in the back.
Wait. Can I ask you a question just now? I'm interested in you say this can replace the CRTP.
Ben is saying he's wondering if deducing this could replace the CRTP thing. How?
Let's talk about.
Okay, we can talk afterwards. Okay. Another question.
For that giant conditional you have to extract packages from pipers, did you consider having just like two overloads for extract package? One that takes a package and one that takes a piper, and in the package case it's a no-op, and in the piper case it extracts the package and then just call it unconditionally?
Two overloads of the pipe?
No, two overloads of some helper function. That
I thought of that, but and then all this mess, I realized this morning that this is unneeded, and I can just assume that it's always going to be a piper, because once you call it, it gives you a package. Otherwise, if you call up an empty piper, then it's just a no-op, as we saw. I mean, if you call an empty package, it just gives you itself. So you could just assume it's always a piper and call it, and it's going to be always a package afterwards. So that's a way of doing it. But yeah, it's an ugly conditional for now. This took me 2 months to come up with, by the way. I just, it wasn't easy.
Does it work if the function returns void?
I don't know. Do you want to find out? Do you want to try it?
Yeah.
All right. So what's your function suggestion?
I don't know, pipe a string into say hello.
Well, okay, so I need to create a struct. Let's do that right here. Oh, would it work if we return void? And my initial answer is no, but let's try this. Void struct. Okay. And so what? And then I should inherit from. Cannot type when looking up to the side. It should inherit from void.
Call operators take a string view and print it.
Okay. So I'm just gonna do, I'm not gonna do const expert, just auto, count type. Let's do operator, ren, take an std, string u. Okay, and that's gonna just do std, c out, and then sv. Not yet. Someone just whispered cd print. And then I should have my other operator, take nothing, and it should, okay, get ready for this. Well, I can't return it, can I? No, I can return that, that's fine. I return static cast of my parent, which is a piper, of void s. Well, that should be a const. Yeah, let's just do that. Okay, it's a const parent pointer of this, access the make package. There you go. Tellson's is working, and then give it nothing. Okay, and let's just make these consts just to be safe. And that should be, there you go. Okay, so let's see if that works. Let me comment out my example. I'm going to create a void. Well, I need to create an object that I will use. So that's another thing that I didn't mention. You need to create an object. Void s, voider, like that. Okay. So if you call it with hello, do I have string literals? I do. Cool. And then if I do the same thing, is that what you're saying?
Yes.
IntelliSense is not happy. I don't know if I missed something in there, but let's try compiling with it. Ooh. Oh, it doesn't like the string view. I'm just going to make it a const char pointer. Okay, that's why I wasn't happy. Look at that. Nice. That works. But maybe with composing functions, that would not work. But I guess,
As long as it's the last one proposed.
yes, so that works for that. Look at that. Very easy. Okay, there's a question.
So can you like take your voider and then do another pipe and then do some other side effecty thing? Like
What you can do is create like, let's call this v, or let's call it bow. And then you can do like, this is equal to whatever. No, that wouldn't work. What is exactly you're saying? Just pipe it with another.
I'm wondering if we like re-implemented the semicolon like sequencing operation here.
Wait, say that again?
Like did we re-implement the semicolon? So like sequencing, like Ben probably knows, but this is like bind or something in the Haskell.
Okay, I'm not sure I understand that fully, but we can talk afterwards if you'd like. Okay, that's the full implementation. It works. We just did an example. Any questions before it's Jason turns?
You start like 30 minutes, and I don't have to talk.
Yeah, but what more can I say? This is basically it. Okay, all right. Thank you, everyone. This has been Ali Almutawa.